So I'm going to talk today about data scientists, the number that we have, the number that we're going to need, educational pathways to become data scientists. And so kind of going through the talk, it's going to be motivation of the problem, talking about boot camp history. I work for Galvanize, so I have a dog in the fight. Talk about my perception of how our company and this educational pathway addresses the gap, and how individuals can be successful along this path. So who am I and why do I feel qualified to talk to you about this? So my name is Joe. I finished my Ph.D. in physics from the University of Florida in 2010. Here's a picture of me at the Large Hadron Collider, which is what I did my doctoral work on. And I started doing data science as a title, although I would say that the work that I was doing at that time was pretty indistinguishable. In 2015, I started working for a defense contractor. At the time, it was called Sotera Defense Solutions. It got purchased by a different defense contractor just before I left. But I actually worked alongside Travis and Peter on the X-Data projects at DARPA. So the history of that is that the government thought it was crazy that they kept paying defense contractors to develop software and then buying the products of those of that development from them from DARPA. And so some enterprising young fellow came in and said, why don't we force DARPA programs to make open source software? And then all of a sudden the X-Data project was born. So as I mentioned, I currently work as an instructor here at Galvanize, particularly in the data science program. So my primary occupation is in fact training people to become data scientists. I also do research in post-secondary education. So I look at metrics of success and people from different backgrounds than traditional students, and ways that they are successful, and look at analyzing the challenges that they face that's unique to them. I'm actually also working with Austin area high schools to try to get some of the open source tools we're talking about today into education all the way down at those ranks. So I do think a lot about education, and at this point I might humbly refer to myself as an expert in the field of education, particularly when it comes to nerdy things like data science. So to briefly talk about the motivation of the problem, by show of hands, who here is a data scientist or some other variety of that thing? Cool, roughly a third of the audience? Cool. I might imagine that those of us who are not data scientists are vaguely aware of the field and vaguely aware of what somebody who might call themselves a data scientist might do on a day-to-day basis. This is a headline article taken from The Economist from a few years ago now. I think that the picture might be a little embarrassing for them at this point because I think one or two of those companies isn't doing so hot these days. But I do think that the general notion of data science and predictive analytics becoming an indispensably important part of growing companies is going to become more true as time progresses. And so certainly there is the biggest companies in the world will reap the greatest rewards of this because they'll have kind of data that intersects many different walks of life. But I think that the thought of predictive analytics and statistical thinking is actually going to become pervasive down to very low levels. And the analogy that might be useful for us all to think about is web development, right? I'm a child of the 80s. I think that I just missed the cutoff so that I'm part of the hipster generation, although I'd love to be a Gen Xer if I could. But I got one laugh. Talk's successful. But the idea is that in the early 90s, very few companies had a website, right? Like if you went around, you used the yellow pages. When I was in 92, I was using the yellow pages to try to find companies in town for what's a new pizza shop, right? Now, if you start a company, you form an LLC, and you get a web page, right? Like before you even have a product, you have a web page. And so while we're not doing kind of ground-up web development, I might imagine that we are going to start using analytic thinking from the ground up. And a lot of companies, even today, very small shops, are using Google AdWords and things like that, and are already using the rewards of predictive analytics in their daily work. So it's not such a far-flung idea that even small companies will be using data science. So who are data scientists, and how do we get, how does one become one? So there are no shortage of Venn diagrams showing us, who they are. This one's pretty pervasive. It's the combination of hacking skills, math and stats, and substantive expertise. I actually really like this one a lot more, just because it shows us how we can go awry. It has the same three, but it also has a little bubble for the characteristic of evil. So we all have dealt with that gnarly outside committee member who just thinks up of evil questions during our dissertation. And I would like to give a shout out to my grad school office mate. He did teach me a lot, but I don't think he was evil. I think he was just misunderstood. But all silliness aside, right, data scientists are people who draw upon a very diverse set of skills. And I think that for the most part, you don't pick up these skills by accident. And it's something that we're going to kind of circle back to over the duration of this talk and revisit this notion of how people get this skill set and how we pick up this set of skills. But it's just something that I kind of want to plant in our psyche right now, and we'll circle back to as we talk about this a little further. Okay, so then another kind of who data scientists are map is, this is the data scientist roadmap. And I believe it starts kind of right here on the screen, this fundamentals, and you go along the way, and each one of these dots represents a skill set that one would have to pick up in order to be qualified to be a data scientist. Now, of the data scientists in the room, who here has not seen this image? I think it's a pretty, you've never seen this before and are a data scientist? Oh, really? Okay. So this was a really common thing to flash in talks maybe 3 years ago. I've seen it a lot less because of the point that I'm making is it's patently ridiculous. But it was shown over and over and over. And I know a lot of data scientists. I know a lot of very, very talented data scientists. And I'm extraordinarily confident that if I showed them this diagram, none of them would say that they have every single one of these white little bullet points addressed in the skill set, right? So the expectation of what the skill sets of a data scientist are maybe more in line with something out of fantasy, right? Of what we need to do. And 3/4 of the things on this page you wouldn't use in your day-to-day life, right? As a data scientist, you would not use all these things. A lot of these things are complementary, and like if you know how to use one, you don't need to know how to use the other. So what's the result of maybe some of these ridiculous requirements for the job is that if we do a quick search on Indeed, you will see hundreds of unfilled positions of data scientists, and they all pay 6 figures, right? I cannot think of, if we were paying janitors 6 figures, I don't think that we would have a lot of unfilled, right? If we have reasonable expectations of what the entryway is, of who can be these things, and what the pathways are, then I don't think that we would have hundreds of unfilled positions. Cool. So I'm going to shift gears a little bit and talk about some enterprising young person's idea on how to address this problem. So if we look at Hacker News way back yonder, there was this post, and it was, want to become a web developer? Are you based in the Bay Area? Can you take the next February and March off? And he launches into what would become the basis of the coding bootcamp, right? And they emphasize that they're going to take 8 weeks, and this is the thing that you're going to do. For 2 months, you're going to sit in a room, and you're going to have somebody who knows Ruby on Rails just kind of whop you on the head for 2 months until you now know Ruby on Rails. And this started in 2011, right? So this has happened quite a while ago. And this actually was the basis for the first kind of immersive program, incubator, boot camp, whatever you want to call it. And so the question might be, well, why would somebody make this venture? Why would somebody do this? And there seems to be a pretty strong misalignment between the things that are asked from job requirements and things that are asked in theory. Now, I don't know how many of you still work with people very young in their career or are yourself a young person in your career. But one of the things that categorically makes people tear their hair out is it's a junior developer role that requires 2 years of experience. And if you do this at your company, stop doing that. Like if it's a junior position, if you can demonstrate that you've built something as an academic project, like then you can do the job, right? But 2 years of experience is very disheartening for applicants, and it's pretty silly too. Out of another show of hands, just as a fun little interactive thing, who here, as a part of a job interview, has been asked to program up depth-first search? Show the hands. I know that there's more than, yeah, okay. So, and who here, as part of their work, has ever had to program depth-first search? Really? It's so surprising. Okay, so I've been asked to program depth-first search on no less than 5 job interviews, all of which I had no computer science fundamental like work that I was doing on my day-to-day basis. And so again, the connection between what we teach in theory and what we teach and what's needed to do the job, there was misalignment. So again, computer science education's teaching C++, they're talking about kind of these theoretical things. And really, the folks at Uber, they wanted somebody who could build something. They want, we give you a task with real goals as far as making something into this world that did not exist before. Can you do it? And it's a pretty binary question. Can you do the thing that we're asking you to do or not? And as a result, there's been growth in the industry, right? So if we track over time, we've had an order of magnitude growth over 4 years. We should have 2018 data in here. We don't, but it's a growing industry because there is a real need in industry for people who just have day one, can you produce skills, and there is not enough people to fill them, both in web development and data science, although I'm really only qualified to talk about one of the two. And the number of places have exploded, right? So we have a whole different variety. A lot of them have different emphasis. I think that a good number of these are particularly focused on web development, but we also have a lot of folks adding to the data science community. And so how do programs like this address the gaps, and how do we kind of maybe merge what our preconceived notions of who data scientists are and how they come to be with this new reality? Well, I want to use an analogy from machine learning. And we talk about loss functions in machine learning, right? And those of us who aren't data scientists, it's basically the way that we coerce the algorithm into getting the right answer. We say, hey, you make some prediction, and if you are right, we applaud you, and if you're wrong, we bop you on the head, right? And we put a lot of emphasis on choosing the right loss function, because if we don't, we can create local minima. We can create these little patches where it seems like we're doing a good job, because if we move a little bit to the left or we do move a little bit to the right, we do comparatively worse, but we're not really doing the best possible job that we could, right? And that's the whole idea behind picking the right loss function. Well, the purpose of a college education is to get a well-rounded education. There's nothing wrong with that. My life has benefited greatly from having great access to great universities. So I'm not bemoaning the purpose of education. But categorically, if you asked an 18-year-old, why are you going to college? The answer would almost certainly be to get a job, right? And so when there's a misalignment between you as a consumer, what you think you're getting, and what the company is providing, there's going to be a tension there, right? So I just kind of wanted to barnstorm highlight. One of the hoops that I make my graduates jump through is that I film videos of their capstone presentations. And so we have, and one of the slides that is in every single one of their talk, because I force it, is that they do a technology stack slide, right? Where they have a slide where they talk about what they used to do their projects. And as we kind of circle through, we can see we have Python, we have AWS, we have scikit-learn. And they're going to look redundant, so I'm only going to show 3. But we can see that we have the things that we've been talking about all day, right? These open source tools that are ubiquitous within companies. And they all come out having built a project that works, that uses the technology that companies want, right? And that absolutely positively is the standard. Can you do the thing that you're being asked to do? And that is the standard that every single one of these people that come out of this program meet. So circling back and again thinking about the kind of the milquetoast version of this Venn diagram, right? We have the hacking skills, the math and statistics knowledge, and the substantive expertise. And I think also a lot of emphasis is afforded to the top 2, right? We oftentimes spend a lot of time thinking about the hacking skills. We oftentimes spend a lot of time thinking about the math and statistics knowledge. But sometimes we don't afford a lot of thought to that last bullet, right? That substantive expertise. And I have one more job posting, right? That, you know, again, just looking at LinkedIn, we have these various requirements where it's like, hey, we want you to be familiar with this, we want you to be familiar with this, and then we also want you to be familiar with this, right? And that the first things are kind of, you know, I could copy and paste them from any data scientist job posting and place them into another one, they'd exist. But they'd also want people to have experience working with healthcare data, right? Now, I know an awful lot of talented computer scientists. Most computer scientists are also very good at math, so it would be reasonable for you to go through, to study hard as a computer science major and end up with a lot of the qualifications to be a data scientist, right? But I don't know a lot of computer scientists that are also experts in healthcare, or are also experts in the automotive industry, or also experts in whatever, right? And as we have seen, a lot of data scientists need to be communicators who really do understand the industry, right? And we can say that the first 2 are important because maybe the personality types we have, they're the funnest and most interesting to us. But I really think that those of us that are very successful in the field don't sleep on the idea of the importance of the business aspect and the non-technical aspects of our role. And I see more and more with my graduates that I am surprised at who is very, very successful and who does okay based on that one, you know, quality. And I've learned a lot in this role of how really indispensably important this last bullet point is. So I want to switch gears a little bit and bring in some information from some of that other research that I do. So the Center for the National Center for Educational Statistics publishes what they call it's a large survey of every post-secondary education institution in the country. This includes 4-year universities, it includes 2-year universities, what we might call community colleges, and it even has other programs that are not community colleges, but they call them less than 2-year programs. And this survey also publishes an awful lot of information about the institutions, what characteristics they have, kind of gives us an ability to do an apples-to-apples comparison of post-secondary education institutions. And if I look at the passage rate just for 2-year schools, we can see that we have like a very, very clear bimodal distribution here. There's one group of schools that tends to do really well. There's another group of schools that doesn't do so well. So part of my research, I'm doing some data mining, trying to find characteristics that help us make predictions about an institution so we can help get insight into what that means, right? The very best predictive variable we have in this is whether or not the institution allows you to bring in AP credits, right? And so if we look at the same distribution, there's some of the schools, as I mentioned, that the previous image was 2 and less than 2, and so some of the schools don't even record that. That's why you'll see the relative shift in the bumps. But we can see for those who record this information, those schools that accept dual enrollment credit have a hugely successful rate of passage, and those that don't. What might we infer from this? Well, I have some insight because I look at other universities, but incoming preparedness matters, right? Those people coming in with dual enrollment credits almost certainly view these institutions as places that they're going to go. They're going to finish up quickly. They're going to save a buck or two from going to big state U down the road and paying for a dorm for the first year, and then they're going to move on in their career, right? They have a plan. They have a vision and insight into where they're going, and they know what they would like to do ultimately. And those people who don't are going to struggle more. Now, I don't know how many young folks you all get to work with, but I don't know a lot of 18-year-olds that know about the field of data science, right? I don't know a lot of 18-year-olds that really feel like, yeah, I'm going to start working on AI tomorrow, right? Now, there are certainly a ton of super talented, smart young people out there. And I'm not saying that those people should not have a fast track into the field, but there's also a lot of really, really smart people that come to love these things later in life. So here at Galvanize, what do we teach? Obviously, we can't teach everything from that last bullet, and as much as I talked about how important it is, I'm not qualified in almost any field to talk about those types of substantive expertise. And B, I'm just not interested in teaching that because I'm not any good at it. But we can work with people on the hacking skills and the math and stats knowledge. And I'll circle back to this picture because I want to say that incoming preparedness, if it matters in one domain, I can't then shift gears and say, oh, it doesn't matter how ready you are here, right? I have to be logically consistent. And if I'm saying that incoming preparedness matters, incoming preparedness really matters, right? So when folks are coming into the program or coming into any program or course of study, particularly when there are two, let's say, complementary sets of skills that folks are trying to pick up, it's really, really important that one of the two already kind of exists, right? So for most of the students that I come in, they have some type of technical background. I'll either have somebody who's a statistician already or a computer scientist already, and then they pick up the other bit, right? You can kind of lean on, hey, if I've already worked as a software engineer, I can lean on that skill set as I'm integrating this new kind of circle of knowledge into my old abilities. It's really, really, really hard to learn both at the same time. Overwhelmingly hard in most cases. And that's all I had for prepared remarks. I just kind of, again, re-emphasizing the notion that when we're thinking about data science pathways, I do want us to think about that experience and that life experience as being more and more important. And again, just as a person who's worked with a lot of people, I've had my expectations subverted as far as who will be successful, because that last bullet point, which is almost always underemphasized in folks in our community, it ends up being really, really important. Cool, thank you. Any questions?
So you're kind of painting a picture of like data science being like this magical kind of place, and you have to have a lot of experience, and maybe even the skill set is like evolving, and there's other things. But a parallel here is like a law degree, right? Or an MBA, right? You don't get into MBA, into top MBA schools without experience. You don't get into law degrees without a lot of, like, at least the good ones, without a lot of experience of writing and doing a lot more skills than you finish it up. I mean, data science to me seems like I see a lot of schools trying to shove data science as a whole discipline early in the curriculum when they haven't built those skills. And so I kind of interested in your viewpoint of like, is this, should you follow the path like a law type degree or medical degree where it's building, it's like the capstone of a career rather than the fundamentals?
No, I think that that's a really good point, and it kind of goes into what I was saying. Like, there's very few 18-year-olds who think, oh, I'm going to go work on AI, right? And it's not because they're not.
That's true.
Well,
but yeah, I mean,
so
I think the same number who think I want to be a lawyer think I want to be an AI person.
So I don't have a kid, or I haven't know a lot of folks in high school, and maybe that has shifted since the last time I regularly interacted with high school students. So I'll say maybe that's fine. Yeah, it's tough to have such a diverse set of education crammed down people's throat. Now, if somebody's super interested in it, we've found that if you can find the why, the how works itself out, right? If somebody is that motivated 18-year-old that they desperately want to work on AI, they're going to figure out how to traverse a course of study and make it happen, even though it is extraordinarily difficult. But I tend to find that, particularly with something that's a new field, people in the past have become lawyers and doctors. I'm going to go pre-med or I'm going to go pre-law because their parents said, oh, this is a good career, right? Or they had a lot of shining examples of like, oh, you do this and like, you can grind it out, you can check the boxes, and if you are a lawyer, you will be well paid. It's kind of less true now. Being a lawyer is less of a safe bet as far as paying for your law degree even. I think that there's been a whole rash of lawyers declaring bankruptcy because law school is really expensive and things like that. But yeah, I do think that there is definitely room for supplementing people who are interested in getting them a skill set to complement an existing skill set, to grow, and there is a lot of value in having some experience working as a software engineer or as a statistician before you make that transition. I don't feel like I've addressed your question because I'm seeing eyes going up that direction. So, do you mind clarifying if I've kind of completely missed the mark?
Well, I mean, with a lawyer, like you don't say you stop the skill set. You don't say, and a doctor, you don't say, well, you don't need to learn how to patch up how to do sutures or how to do some fundamentals. You give them more training and you elevate their position. But I feel like what you're advocating here is like actually just make it easier to become data scientists. Everyone will be data scientists. And I think that's a controversy in our field that we should hold ourselves up to higher standards and maybe ratify more of those standards, but realize it's a hard thing to do.
So I'll make 2 points. If you ask any ER nurse if there's a doctor in this world that can set an IV, I'd say that like it's more of a rarity that a doctor can set an IV than the normal case. And maybe what I'm instead advocating on behalf of is that as the demands of data science are going to continue to grow, we need to winnow out junior data science positions, right? And the vast majority of the data science job postings you'll see are, I want a PhD in a quantitative field and 5 years of experience, right? Now, there's some good motivation for that, right? Data scientists often are decision makers. Maybe if we're thinking of kind of like hierarchies within team, they are leaders of small teams. And so there's a lot of good motivation for wanting somebody who doesn't need a lot of management for initial data science roles. But as the amount of work is going to increase, and it will, right? We need people that are motivated, have day one skills, and maybe would benefit from a little guidance, right? And so I'm not saying that traditional paths to data science are wrong, right? I benefited from that. It would be pretty hypocritical for me to say like, you shouldn't be hiring PhDs. I'm just saying that if that's the only way a large company sees as building their data science staff, the number of PhDs that are graduating on a yearly basis whose goal it is to become a data scientist is pretty small, right? As a physicist, I can tell you I did not go to grad school to become a data scientist. And I don't know anybody who goes to physics grad school to become a data scientist. I don't know anybody that went to stats grad school to become a data scientist. Now that may change because the field's become more popular, but now computer science, it's a little bit less of a leap of faith, right? So I'm sure that there are, computer science Ph.D.s that may be their intention, but that's an awful long track just to get ready to do a job, right? And should we hold ourselves to lower standards? No, but should we be self-honest about like what we're doing on a day-to-day basis and what the actual standard for starting the job is? I think that's a reasonable debate. There's also someone in the back just.
Yeah, I wanted to ask about kind of what is going to be done to address some of the soft skills that are needed by data scientists. I know in my world, I have to go and talk to people who, I don't know what an average is. I don't know what a standard deviation means. And a lot of times, in a lot of these programs, what I've seen is, I'll teach you the math and stats knowledge and the hacking skills, but I won't teach you how to look someone in the eye and explain to them a complex topic in a way that the 3-year-old can understand. And I think that that's something that a lot of should be addressed, I guess. Is it being worked on?
So I can't speak to every program in the world, right? I can only talk about my experience, but that is actually something that we specifically address. We do have review days. We do have communication as an emphasis. In their capstone talks, we make an emphasis that you're not just talking to substantive experts. You're talking to people who may be recruiters, maybe from HR, maybe are somebody else on the team, right? And so, if we want to show, how our model's doing, which we all want to show how hard we worked and how good we did, right? We show a ROC curve and we say I got an AOC score and a precision and recall, and like every single one of my students, like, first round of talks, they have all these metrics and it's like, stop. Like, would a very intelligent high school student understand that? No? If you put a number on that screen, you have to explain it. And these are 4-minute talks, so you can't explain all those things, so you got to choose one. And so, yeah, we do emphasize that a lot, and it is absolutely an indispensably important part of the skill set is communicating with non-technical folks.
Yeah, for those of us that are old enough not to be able to get a job in Austin and that have substances experience and hacking skills and whatnot, is salary really impressive in Austin? I was here a couple of months ago where you guys had the Galvanize alumni talking about their salaries and what was life after they graduated, and salaries just did not seem really impressive. So I wanted to get a sense from you as
Where are you coming from?
I'm sorry?
Where are you coming from?
Where am I coming from?
You said that you're not from Austin?
The folks actually graduated from here.
Okay. So I've had people who in 3 months have doubled their salary. So if you don't think that a $100,000 starting salary is impressive, that's fine. That's a great life you've winnowed out for yourself. But many of my graduates are very happy with the amount of money they're making. We're not the San Francisco Bay, right? So I don't think that. I think that there's only one graduate of the program that's broken 2K from the Austin campus as their first thing, but they also had a ton of experience in other complementary fields. But a lot of the people that are coming into the program have been working as high school teachers or other things, and I can say that they're all doing much better financially than they were before. I would also say that pure money is probably a bad motivation to do a program like this. There are easier ways to get rich. You have to do the program because you really like being right all the time and arguing with people, right? I also have a secondary, completely non-connected goal of I want to make being nerdy uncool again because I think it's important that people that are aspiring to be nerds are willing to fight a lot, and I think that's important. Yeah, exactly.
Hi, thank you very much for very interesting presentation. Can we go back to the slide with that screenshot from Hacker News about the very first bootcamp ever offered in history? Yeah. So what looks interesting here for me is this line: no computer science background required. Now, in my life, I hired maybe 500, maybe more people, mostly engineers. I interviewed a few thousand. I can hardly imagine hiring a person who knows a programming language, but who doesn't understand fundamentals of computer science. Now, not necessarily that person actually has computer science background, that could be math, or that could be engineering, but I don't believe it's possible to master programming without having some kind of STEM background. And from this perspective, I'm not entirely sure that the promise of those bootcamps makes sense for people who don't have any STEM background. So my question is, that was the background. Now the question is, in your experience for data science bootcamps, what is the ratio of people who enter those bootcamps with no STEM background, nothing knowing about engineering or science, and still after the graduation being able to successfully work as computer scientists, versus people who actually did have STEM background before the bootcamp? Thank you.
So there's a couple things in there. I would say that the market generally disagrees with your thought that people with no STEM background can't become engineers, right? There's a lot of very big companies that have hired graduates for pure engineering roles. Those folks have gone on to be very successful. I'm also going to be, I'm willing to be honest, like, as with any school, not every person that comes into the program is an all-star, right? We have people that are very good that come in, and that makes my job easy, right? If you come in with a Ph.D. in computer science, like, I have to move the needle pretty small distance in order to land you somewhere and have you be successful. And I do have folks like that come in. Yeah, without a doubt, those people are easy to teach, right? But I've had people that have come in who were high school teachers, are now working at Facebook, right? I've had people who are, come in with other backgrounds, and like I said, doubled their salary over the course of 3 months and do leave able to build data science projects. Now, would they need management? Sure. Like, folks that come in junior levels may need management. I can also say that I know Ph.D.s that have come into things and don't know what a random forest is. One was me, right? I got hired as a data scientist, and on my first job, I was asked, okay, hey, we have this problem where we have this big Spark cluster. I want you to connect to the Spark cluster, and we're trying to do this, and I want you to build a random forest. I literally, in the string of words that were said to me by my manager, I didn't know what any of them meant, right? So certainly, people from STEM backgrounds, I'll be a little bit arrogant because that's where I'm from. I think that they're sharp people. I think that they're good at figuring things out and digging in and learning things. But it's an incomplete picture.
But in terms of numbers, what is the difference of success rate?
I don't make up numbers off the top of my head. I'm a numbers guy, so I don't know off the top of my head, and I'm not going to try to make one up.
Hey, looking from the other side, like from the industry or the companies, I feel, or my concern is like we are assuming like a dev if we are hiring this kind of graduate from bootcamps people, since if we hire this data scientist, maybe you will need a machine learning engineering, like almost on site on him, and also a data engineer or stuff like that. What is your concern about that? Because like to get it on production, there is a lot of like a big gap about some analysis. Doing some analysis.
So I can use one piece of anecdotal evidence from my graduates in a particular company in town, Cerebri AI, right? So Cerebri AI was a company that had been hosted here. They hired, I think, like 5 graduates across like 3 classes. They moved across town. And they also hired people from more traditional tracks. So because we emphasize hard skills like Spark, like Postgres, so nobody leaves here without being able to write an SQL query. Nobody leaves here without being able to connect to a Spark cluster and do some simple things, right? They were able to build deployable products with a reasonable amount of ramp-up time. The PhDs that they were bringing in, because PhDs are trained to tinker and think about things deeply and blah, 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 they really struggle to get things working in production because that's just not what you're trained to do, right? And while I'm willing to toss out this anecdotal example, I've heard that's more the norm than like some exception, that folks from academic backgrounds really aren't used to deadlines, really aren't used to doing things on a set time frame. The phrase, the perfect is the enemy of the good, really doesn't mean anything to them. And so there are certain realities to working in the real world that I promise you I engineer into my version of the program that most academics don't encounter over the duration of their careers.
If I could just make one follow-up comment. How much would you say? How much would you say, like a data scientist is a person who undertakes a research project versus somebody who implements something that you already understand what you want? I think that's where you draw the line between like, is a PhD going to be useful?
Yeah, no, I do think, so the talk is not supposed to only be PhD bashing. The only PhD I'm trying to bash is my own. I'm trying to be a little self-deprecating. But yeah, most people who get a PhD are pretty smart, right? They're pretty hardworking. They're not just the foibles that I'm bringing up. I'm just saying that if we're thinking of some gold standard where a PhD is a person who has no shortcomings as they come in and don't have to learn things on the job, I don't agree that most PhDs also don't have something to learn on day one of the job, right? And so I'm not just trying to categorically like be mean to my compatriots who also made the mistake of going to grad school.
There's a lot of different kinds of data scientists.
Yeah, exactly. And I think that I'm getting the shepherd's crook that's my time. Thank you very much for your attention and some of the great follow-up questions. If you want to chat more, feel free to find me.